Hello friends, welcome back to my YouTube channel. This is a continuation of my discussion on molecular diffusion, and this would be part number 11. In part number 10, I had discussed one numerical example that was based on molecular diffusion through binary gas mixtures. And in this video, I will be discussing another numerical that is based on molecular diffusion through binary gas mixtures. So I am calling it as numerical example number 2. This is based on molecular diffusion through binary gas mixtures. To begin with, we will look at the numerical statement. An open circular tank 1 meter in diameter contains N propanol at 25 degrees Celsius. The liquid N propanol is exposed to atmosphere in such a way that the liquid surface is covered with a stagnant layer of air 5 mm thick. The concentration of N propanol beyond the stagnant layer is negligible. The vapor pressure of N propanol at 25 degrees Celsius is 20 mm of mercury. If N propanol is worth Indian rupees 370 per liter, what is the value of loss of N propanol from the tank in Indian rupees per day? The diffusivity of N propanol in air, it is 0.02 meters square per hour. So basically there is an open circular tank whose diameter is 1 meter, and N propanol is stored in this open circular tank at a temperature of 25 degrees Celsius. The liquid N propanol, it is exposed to atmosphere because it is an open circular tank. N propanol would be exposed to atmosphere in such a way that the liquid surface is covered with a stagnant layer of air whose thickness is 5 mm. So in the open circular tank where N propanol is stored, on the surface of N propanol a stagnant layer of air is formed, and thickness of that layer is 5 mm. Then beyond this layer, beyond the stagnant air layer, the concentration of N propanol, it is negligible. Vapor pressure of N propanol at 25 degrees Celsius, it is given to us, it is 20 mm of Hg. If N propanol is worth Indian rupees 370 per liter, what is the value of loss of N propanol from the tank in Indian rupees per day? The diffusivity of N propanol, it is given to us with the diffusivity of N propanol in air, it is 0.02 meters square per hour. So this is the numerical statement. Now let us first of all list what is given to us. The given data. So you have N propanol stored in a circular tank, and I am going to show it schematically. So this is a circular tank and N propanol, it is stored in it. It is open to atmosphere. That's why a layer of stagnant air is formed on the surface of N propanol. And what is the thickness of this layer? This is stagnant layer of air, and thickness of this layer is 5 mm. So basically what is happening, N propanol, after vaporizing, the vapors of N propanol, they will be diffusing through this stagnant layer of air, and once they come out of the stagnant layer of air, they are lost in the atmosphere. That is, at the end of the stagnant layer, the concentration of N propanol, it is negligible. The diameter of the tank is given to us, it is 1 meter. N propanol, it is lost because it is kept open to atmosphere. So N propanol, how it is lost? N-propanol is lost due to evaporation from the top surface. So it will be evaporating from the top surface, and then in this way it will be lost. The N-propanol vapors then diffuse through air, through the stagnant layer of air, as I said. N-propanol we are going to denote by A, and air we are going to denote by B. That means in this case two components are involved. One is N-propanol vapors and air. So N-propanol vapors we are going to denote by capital A, and air we are going to denote by capital B. So this is, since air is stagnant, so this is a case of A diffusing in stagnant B, and accordingly we will be using the equations. The equation that is applicable for the case of gas A diffusing in stagnant gas B. Length of the diffusion path, it is the height of, or the thickness of the stagnant layer of air. So in this case, it is thickness of the stagnant layer of air. We are going to denote as per our notation. This is small z, it is 5 mm, and I am converting it to meter. So it will be 5 into 10 to the power minus 3 meter. Temperature is 25 degrees Celsius, and we have to convert it to Kelvin. So it will be 25 plus 273.15, that is 298.15 Kelvin. Pressure is atmospheric pressure, that is pressure is 1 atmosphere, which means it is 1.013 into 10 to the power 5 Newton per meter square. Then vapor pressure of E, that is vapor pressure of acetone, it is given to us. We will denote it as PA0. It is 20 mm of Hg. We will convert it to Newton per meter square. So PA0 will be converted to atmosphere by dividing with 760. So 20 upon 760 atmosphere, and in 1 atmosphere there are 1 atmosphere is equal to 1.013 into 10 to the power 5 Newton per meter square. So in this way you can convert PA0, which is in millimeter of mercury, to Newton per meter square. So first we are converting it to atmosphere, and then by multiplying with 1.013 into 10 to the power 5 we are converting it to Newton per meter square. So that gives us PA0 as 2665.789 Newton per meter square. Then the diffusion coefficient of A in B, it is given, but it is given in meters square per hour. DAB is 0.02 meters square per hour. We will convert it to meters square per second. So this hour will be converted to seconds. So therefore DAB will be equal to 0.02 upon 3600, because 1 hour contains 3600 seconds. So therefore DAB will be equal to 0.02 upon 3600 meters square per second. That is, DAB comes out to be 5.56 into 10 to the power minus 6 meters square per second. Let us move ahead. The cost of N-propanol in Indian rupees per liter, it is given to us. So let us denote it as capital C. So capital C is 370 Indian rupees per liter. What is the objective? The objective is to find out, to calculate the loss in Indian rupees per day. Since N-propanol is lost into the atmosphere, and we are supposed to find out the loss in Indian rupees per day. So this is the objective. So let us start solving this numerical. First, we should know which equation is applicable. This is a case of A diffusing in non-diffusing B. Therefore, that equation will be applicable. So for our understanding, I am taking the schematic diagram, the circular tank containing N-propanol in it. So on the surface of N-propanol, I will be denoting the surface of N-propanol, the top surface of N-propanol. Let it be plane 1, and the top surface of that stagnant air layer, let it represent plane 2. So diffusion is taking place from plane 1 to plane 2. So if you have to represent it schematically, you can represent it like this. So there are two planes which are separated by a distance of 5 mm, and diffusion is taking place from plane 1 to plane 2, because at plane 2 the concentration of N-propanol is 0, as it is said in the numerical statement. Concentration beyond the stagnant air layer, it is negligible, so that is 0. So diffusion is going to take place from plane 1 to plane 2, and since this is a case of A diffusing in stagnant B, this equation will be applicable. Na is equal to dAb P upon RTZ PBM into PA1 minus PA2. In this case, PBM is given as PB2 minus PB1 divided by ln of PB2 by PB1, which is nothing but the logarithmic average of the two partial pressures of B, that is PB1 and PB2. PBM actually is the logarithmic average of PB1 and PB2. So PA1 is partial pressure of A at plane 1, and similarly there will be partial pressure of B at plane 1. Then you have partial pressure of A at plane 2, PA2, and partial pressure of B at plane 2. So first step, what steps we will have to follow in order to get the final answer? First we will be finding PA1 and PA2, and then we will be finding PBM, and finally we will be finding Na. And this, based on what Na we get, we will be converting this information to loss in Indian rupees per day. So first we are going to get PA1 and PA2. Let us move ahead. So finding PA1 and PA2. Now at plane 1, which is the top surface of N-propanol. So at plane 1, PA1 will be equal to its vapor pressure at the prevailing temperature, which is 25 degrees Celsius, and PA0 is given to us. So therefore at plane 1, PA1 is PA0. Therefore PA1 will be equal to, or PA1 is equal to 2665.789 Newton per meter square, because PA0 is 2665.789 Newton per meter square. Then at plane 2, the concentration of N-propanol vapors, it is negligible, as is stated in the numerical statement. What is the understanding of this? PA2, that is partial pressure of N-propanol vapors at plane 2, is 0. So in this way we get PA1 2665.789 Newton per meter square, and then we get PA2, which is 0, because concentration beyond the stagnant layer, it is negligible. Let us move ahead. Now we got PA1 and PA2. Next step is finding PBM. So for that, PB1 is equal to P minus PA1, because at plane 1 the sum of partial pressures is equal to total pressure. So PA1 plus PB1, this is equal to total pressure, which means PB1 is P minus PA1. So this is what I have written over here. PB1 is equal to P minus PA1. P is 1.013 into 10 to the power 5 Newton per meter square. PA1 we found out earlier, it is 2665.789 Newton per meter square. Therefore PB1 will be equal to 1.013 into 10 to the power 5 minus 2665.789. That gives us PB1 as 9.68 into 10 to the power 4 Newton per meter square. Then we have to find out PB2. So PB2 is P minus PA2. Again the same, you have the total pressure at plane 2 is sum of partial pressures. So PA2 plus PB2, this is equal to total pressure. That means PB2 is P minus PA2. So again P is 1.013 into 10 to the power 5 Newton per meter square. PA2 is 0. You know why it is 0. Therefore, PB2 will be equal to 1.013 into 10 to the power 5 minus 0. That is, PB2 will be equal to 1.013 into 10 to the power 5 Newton per meter square. So, in this way, we get PB2. Now, we know PB1 and we also know what is PB2. So, PB1 is 9.68 into 10 to the power 4 Newton per meter square. PB2 is 1.013 into 10 to the power 5 Newton per meter square. Now, PBM, which is PB2 minus PB1 divided by ln of PB2 by PB1, that is PBM will be equal to 1.013 into 10 to the power 5 minus 9.68 into 10 to the power 4 divided by ln of 1.013 into 10 to the power 5 divided by 9.68 into 10 to the power 4. Okay, now let us get the value for PBM. So we got this equation. PBM is equal to 1.013 into 10 to the power 5 minus 9.68 into 10 to the power 4 divided by ln of 1.013 into 10 to the power 5 divided by 9.68 into 10 to the power 4. So that is PBM comes out to be 2. In the next step, this difference is 2.67 into 10 to the power 3. Whereas log this ratio is 1.027. So that's why PBM is 2.67 into 10 to the power 3 divided by ln of 1.027. That is, PBM is 2.67 into 10 to the power 3. ln of 1.027 is 2.67 into 10 to the power minus 2. So PBM comes out to be 9.996 into 10 to the power 4 Newton per meter square. So in this way, we get PBM. So that ends calculation for this step. We have found PBM 9.996 into 10 to the power 4 Newton per meter square. Let us move ahead. Now after that, let us find Na. Equation for Na is dAB into P divided by RTZ PBM into PA1 minus PA2. Now everything that is required on the right hand side of this equation, and now it is known to us. dAB is 5.56 into 10 to the power minus 6 meter square per second. P is 1.013 into 10 to the power 5 Newton per meter square. R is 8314. So if I am using out of many values for R, I have chosen this value. So if I choose R to be 8314, then its units will be Newton per meter square into meter cube per kilomole per Kelvin. That is, pressure is in Newton per meter square, volume is in meter cube, amount of substance is in kilomole, and temperature is in Kelvin. Temperature is 298.15 Kelvin, and the length of the diffusion path is 5 into 10 to the power minus 3 meter. PBM, we calculated it, it is 9.996 into 10 to the power 4 Newton per meter square. PA1 is 2665.789 Newton per meter square, and PA2 is 0. Now what is left? We just have to put these values in this equation and get Na. So let us move ahead. So Na is dAB P upon RTZ PBM into PA1 minus PA2. Now all values are known. So therefore Na will be equal to 5.56 into 10 to the power minus 6 dAB. P is 1.013 into 10 to the power 5 divided by R is 8314, T is 298.15, Z is 5 into 10 to the power minus 3, PBM is 9.996 into 10 to the power 4, and into PA1 is 2665.789, and PA2 is 0. So that is Na is equal to, this product is 0.562. The product in the denominator is 1.24 into 10 to the power 9, and this difference is 2665.789. So that gives us Na as 1.21 into 10 to the power minus 6 kilomole per meter square per second. So that ends our calculation for this step. We have got the value of Na, which in this case it is 1.21 into 10 to the power minus 6 kilomole per meter square per second. Let us move ahead. Okay, so we need to do few conversions in order to get the loss in rupees, Indian rupees per hour, per day. So let me just tell you what we are going to do. So we got Na, which is in kilomole per meter square per second. So we will be converting it to Ra, which is in kilomole per second. So that can be done if we multiply kilomole per meter square per second with area. So that will give us kilomole per second. Then kilomole per second, we will convert it to meter cube per second. Then meter cube per second, we will convert it to liter per second. Then liter per second, we will convert it to liters per day. So this many liters of N-propanol, they get lost in one day. And we know price of 1 liter, which is given to us. So if you multiply this with the price of 1 liter, that will give you loss in rupees per liter. So that is the approach. So let us understand this. So first we are going to convert Na, which is kilomole per meter square per second, to Ra, which is in kilomole per second. So we got Na as 1.21 into 10 to the power minus 6 kilomole per meter square per second. So we have this. So the loss or the diffusion is taking place through this area, which is nothing but the cross-sectional area of the tank. We know the diameter of the tank. So we will have to multiply Na with the cross-sectional area of this tank to get kilomole per second, that is Ra. So first we will find out area, cross-sectional area of the tank. So that is pi by 4 d square. D is given to us. It is 1 meter. So therefore A will be equal to pi by 4 into d square. That is pi by 4 into 1 square. That gives us A as 0.785 meters square. Now how do I get Ra, kilomole per second? Simply by multiplying A with Na. So Ra will be equal to Na into A. Na is 1.21 into 10 to the power minus 6 and A is 0.785. That gives me Ra as 9.51 into 10 to the power minus 7 kilomole per second. So in this way, kilomole per meter square per second we have converted to kilomole per second. Let us move ahead. Then, as I said, next we will be converting Ra, that is kilomole per second, to Va, which is liter per second. So for that we got Ra just now, 9.51 into 10 to the power minus 7 kilomole per second. Now we will assume that N-propanol behaves ideally, so we can use ideal gas law. So in this case, the ideal gas law will be P into Va, that is equal to Na into R into T. In this case, total pressure, P is total pressure, which is 1.013 into 10 to the power 5 Newton per meter square. Then Na in this case is number of moles of N-propanol, which is nothing but Ra, because we have this value. So it is 9.51 into 10 to the power minus 7 kilomole per second. So we are supposed to convert this kilomole per second to liter per second. So that's why number of moles in this case is 9.51 into 10 to the power minus 7. But we have rate, kilomole per second. So if you use it, use Ra in this equation, Va will be obtained as, first we are going to get it in meter cube per second, and then we will convert it to liter per second. So R is, we have to use 8314 meter cube Pascal. Pascal is Newton per meter square per kilomole per Kelvin. Temperature is 298.15 Kelvin. So if I use these values, so it will be 1.013 into 10 to the power 5 into Va. We are going to get Va, that is equal to 9.51 into 10 to the power minus 7 into 8314 into 298. That is Va will be equal to 9.51 into 10 to the power minus 7 into 8314 into 298 divided by 1.013 into 10 to the power 5. That gives us Va as, and the product in the numerator is 2.357 divided by 1.013 into 10 to the power 5. That is Va it comes out to be 2.33 into 10 to the power minus 5 meter cube. And now we will convert it to liter. And for that, I will have to multiply with 1000. So VA will be equal to 2.33 into 10 to the power minus 5 into 10 to the power 3 liters. That is, VA comes out to be 2.33 into 10 to the power minus 2 liter per second. So in this way, we have converted RE, which is in kilomole per second, to VA, which is in liter per second. Let us move it. So now let us get the loss in Indian rupees per day. So we got VA, which is 2.33 into 10 to the power minus 2 liter per second. The meaning is 2.33 into 10 to the power minus 2 liters of N propanol they are getting lost per second. Now, how to get N propanol lost per day? So for that, we will have to multiply VA, which is in liter per second, with number of seconds in a day. So this is per liter, and if you multiply with number of seconds in a day, we are going to get VA in liters per day. So VA in liters per day will be equal to 2.33 into 10 to the power minus 2 into number of seconds in a day. Therefore, VA in liters per day will be equal to 2.33 into 10 to the power minus 2 into, there are 24 hours in a day, so into 24. There are 60 minutes in 1 hour, so into 60, and there are 60 seconds in 1 minute. So VA in liters per day, it will be 2.33 into 10 to the power minus 2 into 24 into 60 into 60. That gives us VA as 2010 liters per day. Now let us get Indian rupees lost per day. So I will denote it as LA. So LA will be equal to VA in liters per day into cost of 1 liter, which is given to us. It is 370 Indian rupees per liter. Therefore, LA will be equal to VA is 2010 to 2010 into 370. That gives us LA as 7,44,000 Indian rupees per day. So that is a huge loss if you are storing N propanol in an open tank. So per day you are going to lose 7,44,000 rupees, Indian rupees per day. So that is the final answer. So in this way we have got the loss in Indian rupees per day if you are keeping N propanol in an open circular tank. So with this, I will end my discussion for today's video lecture. I hope you have learned how to solve such numericals and then how to make required conversions. So if there are any doubts, you please mention them in the comment section. So thanks for watching this video lecture. I hope you have understood the steps that I have discussed for solving today's numerical. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. In my next video lecture, I will be discussing how to get diffusion coefficients for gases. I hope you will join me in my next video lecture. For now, have a nice day. Bye bye.